Hi, lesson 2.3 is all about finding real zeros of polynomial functions. You'll be dividing to do this. There's two methods, long division and synthetic division. While synthetic division is quicker, it does not always work, so you will need to be able to do both methods. We're gonna start with long division. You're setting it up just like a normal long division type problem. Do watch your exponents. Make sure that they are decreasing, you're not skipping anything. So I'm going to set it up, I always think of like in my little house. So I have 2x to the fourth plus 4x cubed minus 5x squared plus 2x minus 3. That's all going inside. I'm dividing it by x squared plus 2x minus 3. Again, make sure you don't skip any exponents. It goes 2, 1, and then no exponents. So that goes outside. X squared plus 2x minus 3. When I start to do this division, first off, there are 3 terms here. So I'm going to be going over this third term. So I'm going to put my first number here over that negative 5x squared. But I'm looking here at my x squared, and I want to know x squared times what would give me 2x to the fourth. And that would be 2x squared. So that's what I'm going to put up here, and that's what I'm going to multiply this whole trinomial out here by. So that's going to give me 2x to the fourth plus 4x cubed minus 6x squared. Then if you remember from long division, you're going to subtract all of that. So 2x to the fourth minus 2x to the fourth is going to give me 0 there. 4x cubed minus 4x cubed will be 0. Negative 5x squared minus a negative 6x squared is just going to be x squared. Bring down my 2x. Now, since I was able to eliminate 2 here, and I only have 2 terms here, but I'm trying to divide with 3, I do need to put a 0 here, kind of like a placeholder. Then I can go ahead and bring down my minus 3. So now I'm saying x squared plus 2x minus 3 divided by x squared plus 2x minus 3. Which again, I still do just want to look at that first term, and that's going to be a 1 there. 1 times x squared would give me the x squared. If I multiply the rest of that, I get 2x minus 3. I'm subtracting that whole thing, so I end up with 0. That is your remainder. In this case, it's a remainder of 0, so I don't really have to worry about it. But that is my remainder. My answer is going to be up here, the 2x squared plus 1. Okay, I'm sorry, I don't know what's wrong with this PowerPoint that it keeps doing that. Synthetic division. So this is where you're going to look at your coefficients. When I look at this, my coefficient for my x to the fourth is 1. My coefficient for my x cubed, since there isn't one, is 0. Coefficient for x squared is negative 10. Coefficient for the x is 2. Coefficient for the constant, in this case just the constant, is 3. So those are my numbers there. Over here in this little box is where I'm going to put where I'm dividing by. But I'm not dividing by x minus 3. I'm thinking if I set that equal to 0, I would get x equals 3. So I'm actually dividing by 3 out here. That's what I'm using for my synthetic division. To do synthetic division, I have my setup. I bring the first number down, so that's 1, and then I'm going to do 3 times 1, which is 3. I add these two, which gives me 3. Multiply again, the number in the box and the number on the bottom. 3 times 3 is 9. When I add there, I get negative 1. Multiply gives me negative 3. Adding there gives me negative 1. Multiplying gives me negative 3. Adding there gives me 0. This last number is my remainder. And my answer, since I was doing an x to the fourth divided by an x, this is going to be 1x cubed plus 3x squared minus 1x minus 1. To do synthetic division, you can only be dividing by things like this, the x minus 3. You could not divide with an x squared. So like on the first problem where we divided by x squared plus 2x minus 3, that has to be long division. So that's why you need to know long division, because sometimes you will be dividing by quadratics and stuff like that that has x squared. Oh, good lord. Your remainder and factor theorems. Remainder theorem, factor theorem, you guys can copy those down. Basically, if a polynomial is divided by x minus k, then the remainder is r equals f of k. So your remainder's your r here. If I divide some function by this, my answer would be, if I divided by like x minus 3 like we did on the previous problem, if I then went into that original function and did f of 3, that's going to equal whatever the remainder was. So that's the r there. So on the previous problem, that would have equaled 0 if you did f of 3. Your factor theorem, f of x has a factor like this if and only if f of k equals 0. So basically, if the remainder equals 0. That means that whatever you divided by, x minus k, or like from the previous problem it was x minus 3, it means that that is a factor of f of x. So if my remainder is 0, then I've just found one of my zeros. Sounds redundant, but one of your x-intercepts. Use the remainder theorem to find each remainder and state whether the binomial is a factor and thus determines a root. So when I'm doing this, I want to know if this is a factor. So I would just do my synthetic division with my 1 there. I'm going to have 2, my x squared number is a negative 3, and then I have 1, and then I do need a 0 for that constant even though it's not there. Bring down my 2. 2 times 1 is 2. Add that, I get negative 1. Negative 1 times 1 is a negative 1. I get 0 there. 1 times 0 is 0. So I get 0 here for my remainder. My answer is going to be 2x squared minus x for when I divided. So I found each remainder, state whether the binomial is a factor. Because the remainder was 0, that means that x minus 1 is a factor, and it means that 1 is a root, or a y-intercept. Sorry, my bad, totally ignore that, or an x-intercept. Example 2, I want you guys to try to do this, so pause this for a second and work this out, and then go ahead and look at the answer once you've done that. Okay, go ahead and check your answer with that one. Okay, here is example 3. I want you to try to do this one on your own as well, so pause this and then check your answer. Okay, if you check your answer on number 3 as well, first off make sure you got your zeros in there to do those placeholders for the terms you were missing. This is how you write your remainder over whatever you divided by, and when I plug negative 2 back into that original function I do get 8, so that does make sense that my remainder was 8. Right, example 4 I'm going to do with you because I'm telling you what the root is and I want to know the other roots. So to do that, I'm still going to do synthetic division with that. I'm going to use my coefficients from up here, so 1, 5, negative 2, and negative 24. And if it is a root, I should be getting 0 down here for my remainder. Just 24. So yeah, so I do get 0, which means my new problem is x squared plus 2x minus 8. So to find my other roots, I'm setting that equal to 0 and solving that. So I'm going to get x plus 4 and x minus 2 equals 0, which is going to give me x equals negative 4 and x equals 2. So my roots are negative 3, negative 4, and 2. My factors are x plus 3, x plus 4, and x minus 2. The rational root theorem. Sometimes it can be difficult to identify roots of a polynomial. We can use the rational root theorem to give us direction in finding possible roots. So like that previous problem, I told you a root, but if I hadn't, trying to come up with the numbers that you would use for synthetic division. To do that, you list your factors of your leading coefficient and the factors of the constant of the polynomial. The possible roots are the factors of the constant divided by the factors of the leading coefficient. So you're going to do factors of constant divided by factors of the leading coefficient. And we'll do a couple of examples with that. Determine the possible rational roots. Find the possible rational roots and then determine the rational roots. So possible, for this first one, I'm going to do factors of my constant. So numbers that multiply to 3 are positive, negative 1, positive, and negative 3, divided by factors of my constant, which is, or sorry, factors of my leading coefficient, which is just 1. So that's positive and negative 1. So my possible rational roots would be 1 divided by 1 is just going to be 1, so plus or minus 1, and plus or minus 3. To determine my rational roots, I could plug those numbers in here and see which ones are going to equal 0. I want you guys to do all of these and then check them in a minute. Okay guys, I went ahead and wrote your actual roots over here, negative 3 and 1. You can check those, like I said, by plugging these numbers in and seeing which answers actually give you 0. Go ahead and do the second and third one on your own, and then I'll make sure I put those answers up tomorrow at the beginning of class.